Hello, this is Professor Scott Norman at Pittsburgh State University in the Department of Automotive Technology, and this is a lesson on AC systems. We teach AC systems in our mobile climate systems class, and today's a snow day. Normally I would cover this in class, but since it's a snow day, I've been wanting to record this information for my students because I'm afraid that someday the software that I'm using for the animation is going to expire and it's not going to work anymore on the computer. So it's nice to get a recording just so we have it in case something happens. So this is going to be probably a 4, maybe a 5-part series on the different type of AC systems that we're currently using in mobile vehicles. So, that's anything from passenger cars to trucks to off-road vehicles, to farming vehicles, construction, over-the-road trucking and everything like that. So hopefully you enjoy the series. So the first system that you see right here is a capillary system. It's a TXV is what it is. And so when I show my students an AC system when I draw it on the board, hopefully they're able to identify these the 4 main parts on the AC system. So students, so maybe you want to pause this for just a second. And that way you can name the systems. Make sure that you know those before I give you the names to kind of test yourself as far as what these 4 main pieces are. And then you have a 5th piece here, depending upon what this item right here is. So hopefully you figured that out. You got that pause, and now I'm going to give the answer. So we'll take a look at this. And so when you look at an AC system, you first have your compressor, which is the heart of the system. It's doing 2 things. It is creating flow of the refrigerant. So refrigerant is going to come out of this line right here, which is the discharge line. So it creates flow, but it also creates pressure and heat. So I tell students a water pump creates flow of coolant in the engine, but it doesn't create pressure or heat of the system. Well, this compressor, which is driven off the engine, is creating flow, but it's also creating pressure and temperature. So we have the refrigerant coming out of the discharge line right here. Then it goes into the condenser. So the main job of the condenser is a heat exchanger. It is dissipating the heat. So all that hot refrigerant that is inside the condenser is going to be dissipated into the air. So the refrigerant, heat goes from hot to cold. So the hotter refrigerant to the cooler air comes out of the condenser, and then it goes to a receiver dryer in this case. So the receiver dryer is in the liquid line, and so you can see the receiver dryer right there. And then here the refrigerant then goes to our expansion valve. In this case, this TXV is called a capillary system. And on today's cars, this particular valve would be probably really close to the evaporator under the dash, to something that you cannot see. So the refrigerant then is going to go through the evaporator. The expansion valve is a variable restriction in the system. It's a controlled pressure drop, if you want to call it that. Then the refrigerant is again continuing out of the liquid line, going into the evaporator, and so the evaporator is under the dash. And the evaporator's main job is to absorb that heat. So the heat that's inside the vehicle, the hot air that's inside the vehicle, is going to be absorbed by the refrigerant that's going through the evaporator. Then here we have a sensing device on the suction line, the outlet of the evaporator going to the compressor, and so that's our capillary, which is monitoring the temperature of that suction line, and depending upon what that temperature of that line is, it's going to adjust the flow of refrigerant going into the evaporator. So you can see that we have 4 quadrants, and so we draw a line between the 2 heat exchangers is what we do. And so I'm going to play this animation, and we'll see how it turns out on the recording. But so if I draw a line up and down through these 2 heat exchangers, over here on this side by the compressor is going to be the side that is a vapor refrigerant. And then the side that's over here by the expansion valve over here is going to be the liquid side. So, so we got vapor side on one side, we got liquid side on the other side. Then if I draw a line through the 2 pressure devices, the compressor is adding pressure and the expansion valve is reducing pressure. So if I draw a line between the 2 pressure devices, I can say up here on On top is going to be high pressure, and then over here on the bottom is going to be low pressure. So when you look at your 4 quadrants of pressure, if I take a look at this discharge line, and I have to understand there's a high pressure vapor going in that line, going to the condenser, and then the condenser is going to condense the refrigerant. It's turning it into a liquid. So they named it something that made sense. Well, now I'm over here on my high pressure liquid side. So I got high pressure liquid coming out of the condenser. I got liquid going into the receiver dryer. The outlet of the receiver dryer, even though the line's at the top, it's kind of like a big straw. So it's going to pull refrigerant from the bottom, which is going to be liquid and oil, and it's going to pull it out of the top right here. So liquid goes into the receiver dryer, liquid comes out of the receiver dryer. The main job of the receiver dryer is that it has this desiccant in it, and the desiccant is going to absorb moisture in the system. It also acts kind of as a filter in the system versus, if anything in the compressor, debris, you start getting the Teflon on the piston starts to wear off. And if it does make it through the condenser, it's probably going to end up staying in the receiver dryer. There is like a little filter mesh screen in here. And so it's kind of, so probably not much debris is going to get past this guy right here. There's a filter along this like straw mechanism in the receiver dryer. So that kind of acts as a filter. There's a desiccant in it, so it's going to remove moisture. It's also acting as a storage device. So 3 things. But that liquid refrigerant in the liquid line here is going to then go to my expansion device, where again this valve is going to move up and down, and it's going to control the amount of refrigerant. So when I put a pressurized liquid through a restriction, it's going to drop pressure, and as it drops pressure, it drops temperature. So again, I got a low pressure liquid now coming in this quadrant right here, which then goes to the evaporator. And at some point in the evaporator, that refrigerant is going to evaporate. When it does, it absorbs a huge amount of heat, and it turns it into a vapor. And so that vapor then goes back to the compressor, and it cycles all over again. So I think what's really cool about a air conditioning system is that, its job is to take heat that is inside the vehicle, and that heat's going to be transferred to the refrigerant. That refrigerant is going to be moved by the compressor to outside the vehicle, which is the condenser. It sits in front of the radiator, and then a fan blows across that, and it takes that heat that's in that refrigerant, and it releases it to the atmosphere, the outside air. And so that refrigerant cycles through and through all over again through the system, thousands, 100,000s of times, and so we'll see if my email just clicked on. I don't know if that's going to show up in the recording or not. We'll see. But anyway, the only moving parts in this system, besides refrigerant moving around, is that you have the compressor, which is the main moving part, and then you got this TXV valve that will open and close a little bit on that. As far as the name of the lines, so we talk about that, so I can't just say, hey, touch this line or touch that line or look at this line here. If I say look at the high line, well, I got 2 different high side lines, and if I say, well, grab the low line, well, there's 2 different low lines here on this side. So these lines have particular names, and so the line between the compressor and the condenser is called the discharge line. So if you grab that discharge line, since there's high pressure vapors in there, it's going to be hot. I mean, you're going to grab a hold of that, and you don't want to hang on to it. That's going to be 150 degrees plus, and you're going to burn your hand if you hold on it real tight. So I kind of tap on it really close or really fast with my fingers, and I kind of tap on it and say, oop, that's hot. Kind of like what you would with an upper radiator hose. You don't want to just grab that thing real hard because you're going to burn your hand. So I would expect that to be hot. If it's not hot, there's a problem. Okay. When I take a look at the liquid line, anywhere upstream of the expansion device, that should be warm. So it should be warm. The line should be warm going, and that's the liquid line. Since there's liquid refrigerant in it, they kind of named it, something that made sense. But that liquid line before the receiver dryer should be warm. It should be warm after. Really, there should be no temperature drop at all between the receiver dryer. If there's, if it's warm going in and cool going out, then that means that there's a restriction in the receiver dryer, which you don't want. That's a problem. So it should be warm going in, should be warm going out, up to the point of the expansion device. So right before the expansion device, it's going to be warm. If you grab that line, After the expansion device, it's going to be cold. It's going to feel like an ice cube. Not cool. I tell the students cool is a problem. It should be cold. The refrigerant may start evaporating a little bit inside that line from the expansion device to the evaporator, and when the refrigerant evaporates, it's absorbing a huge amount of heat. So it's going to be cold. So that's the liquid line. So the liquid line is going to be cold after the expansion device. Then, as you grab that suction line, again, the suction line and the discharge line are the ones that are easiest to find on a vehicle because they're going in and out of the compressor. The suction line is typically the bigger of the two lines, and that's going to be cold also. And so I should be able to grab a hold of it, and it should be cold to the touch. If I see the line sweating a little bit on a hot, humid day, I'm not so worried about it. If the line starts to frost, I am a little bit worried about it. I'm worried about there still being a liquid refrigerant evaporating in that suction line. And if liquid refrigerant gets to that compressor, that's very bad. The compressor doesn't like to compress liquid. Vapor goes in, vapor goes out. And so if liquid goes into the compressor for a long period of time, it's gonna destroy that compressor. So we talk about the four quadrants, and so what the pressure is in each of the four quadrants. We talk about the names of the lines. We talk about the status of the refrigerant. We talk about the temperatures of the lines, because that's what we're using to diagnose the system. If the discharge line is not warm, and the liquid line, if the discharge line is not hot, and if the liquid line is not warm, and if the suction line is not cold, then that's telling me that there's a problem. So now let's talk a little bit about how this expansion valve works. So in this capillary tube right there that's taped on to the suction line, the outlet of the evaporator, we have a little bit of refrigerant. And so that refrigerant is in a hollow tube that goes up to what we call right here is a power dome. And so it's sensing the temperature of that line. And so if the temperature of that line is going up, let's say it's above 40 psi, it's 40, 45 psi, then the pressure, the temperature, again, if the pressure goes up, temperature goes up. If pressure goes down, temperature goes down. So again, if the pressure goes up above 40, then the temperature of this capillary tube goes up high, at 40, and it's going to push down on that power dome right there. And that power dome is going to push down, and it's going to open up that valve right there and allow more refrigerant to go through. So what's happening there is that the reason why this pressure goes up is that I have refrigerant going in, and all that refrigerant is evaporating. And after it evaporates, it goes into a superheat condition. That's the temperature beyond the boiling point of the refrigerant, and it's still absorbing a little bit of heat. If the refrigerant is just boiling inside the evaporator, well, I don't get a change in temperature. I just get a change in state. But if it's a vapor, let's say that all that refrigerant vaporizes maybe about like 3/4 of the way through the refrigerant. Through the evaporator, it still has a quarter of the way to pick up heat and raise temperature. And if it raises temperature, it raises pressure. So what that means is that if the pressures are high, let's say like at 40, 45, above 40 on the suction line, it means that I could put more refrigerant in the system because the evaporator could handle it. So it's going to open up that valve. It's going to allow more refrigerant to go in. As more refrigerant goes in, the point in the evaporator where we evaporate and all that refrigerant goes from a liquid to a vapor moves closer to the end of the evaporator. And so we're wanting just a few degrees of superheat, I call that, in the system. So ideally, I open up this valve, and it's going to put the precise amount of refrigerant in. So I start the evaporation process at the beginning of the evaporator, and right at the end of the evaporator, it ends the evaporation process and picks up just a few degrees of superheat, 2-3 degrees of superheat. Hey, I know that it's working as efficiently as possible. Let's say that you start your car up on a mild day. It's only 50 degrees outside, and there's not really a heat load inside your evaporator. Well, what's going to happen is that the suction line is going to be reading pretty low. Okay, it's going to be, and the reason why is that this valve is going to allow refrigerant to go through the evaporator, and since there's no heat, the inside of your car is not very hot. There's not enough heat to cause that refrigerant to evaporate. So it's going to start evaporating on the outlet of the evaporator in that suction line, and it's going to pick that up. And again, refrigerant evaporates in, negative 15 degrees, negative 21 degrees, so it's pretty darn cold. And so it's going to drop below 20 psi. And when that does that, the capillary tube is going to sense that temperature drop. So 20 psi, lower temperature around 20 degrees, depending upon the refrigerant. And so that low pressure is going to be sensed by that capillary tube, and so there's less pressure pushing down on the power dome. And so by less pressure pushing down on that, it's going to close the valve. And as it closes the valve, it's going to restrict the amount of refrigerant go through, which is going to move the boiling point of the refrigerant closer towards the beginning of the evaporator. So it's a feedback system, and so the expansion device is constantly, opening, closing, trying to get the perfect amount of refrigerant going through the evaporator, so all the refrigerant vaporizes before it exits the evaporator, because again, we don't want any liquid going to that compressor. If I click on this expansion valve right here, you kind of get a little bit better idea as far as how that works. And so right now the valve is open, and the refrigerant's going through the valve, and so now all of a sudden the valve closed. And there's less refrigerant. You kind of see the speed of the refrigerant going through is going less. And now the valve is open again, and there's more refrigerant going through. So the key to remember is that if the suction pressure is up, above 40, well, that's going to cause the valve to open because the evaporator could handle more refrigerant. If the suction pressure drops down below 20, then that means that we're putting too much refrigerant in, and again, you're getting some boiling refrigerant, some evaporating refrigerant in the suction line. So that means there could be liquid in that suction line, so it's going to close the valve. And really, the valve doesn't, just open, close, open, close, open, close. It kind of finds a happy medium depending upon what the heat load is inside that vehicle. One of the questions that I'll ask my students is, hey students, what would happen if this capillary tube right there, the tape that's holding it on the suction line falls off? What will happen to the system? And so you may want to pause the video to think about this a little bit, because I'm going to give you the answer here in a few seconds. But again, and that's a common thing, what's going to happen? Well, so here's the answer now. So what happens is that if this tube isn't able to sense this line temperature, it's going to read higher than what it's supposed to read. It's going to read higher. So it's not reading the temperature of the line, it's reading the temperature inside the case of the evaporator. And so instead of reading 30 psi or 35 psi or 40 psi, it could be reading 70 psi. So it's going to be higher in pressure, and that high pressure is going to come up and it's going to push down on this power dome, and it's going to open up the valve is what's going to happen. So that's a very bad situation, because if the valve stays open too much, it's going to flood the evaporator, I call that. So you're going to have liquid going into the evaporator. If you don't have a big heat load, you're going to have liquid coming out. You're going to start sending liquid to your compressor, which, your compressor could pump liquid a little bit, but, I've seen this before, and you can hear that compressor. As soon as it starts pumping liquid, it sounds different. And of course, it's going to damage a compressor if you drive that all summer long with that TXV not able to move back and forth. The other scenario, besides it being stuck open all the time, is stuck closed all the time. So if it's closed all the time, like it's closed right now, I see it in the picture, it's going to put very little refrigerant in the system. The AC is not going to work very well. But, if you're looking at like operating your air conditioning in like March or in April or May, well, you don't need a lot of refrigerant to make your car cool well, so it may only be putting just a little bit of refrigerant through the system. The problem that you're worried about is that it's putting not only a little amount of refrigerant, but a little amount of oil. So if you run the system very long with, let's say, a restriction in your TXV, it's restricted because it's stuck or there's debris in there, rust in there, whatever, it just can't move. That could eventually cause a compressor to fail, just like a stuck open condition, because not only do you have lack of refrigerant, but you also have lack of oil going through the system, which is bad. Here, I'll show you the call outs just so you can kind of see where everything is at in this animation where you can see the capillary tube and the diaphragm going up and down. Again, I call that a power dome is what I call that goes up and down. And that's kind of the basics as far as how a capillary system works. And again, we still see these on modern, 2022 vehicles. A lot of imports we'll see this type of system on it. So if you take a look at your AC system and you take a look at your bulkhead, and I'm looking for the liquid line. Normally the liquid line is the skinny metal line, that's going through the over on the passenger side, kind of by the fender. And normally I'll look, and if I don't see an H valve, which is the other type of TXV, in the bulkhead, and I don't see an accumulator in there, or if I do see a receiver dryer, in that liquid line somewhere, then I know that, wow, it's a capillary system. And again, these are down under the dash, typically right next to the evaporator. So this line between the TXV and the evaporator, you can't get your hand on. It's all kind of one piece. Also, on a lot of cars, the condenser and the receiver dryer are kind of one piece too. The receiver dryer is bolted right onto the side of the condenser. So the line between the condenser and the receiver dryer, there is no line. It's just connected directly to it. So that's something that they've done fairly regularly also. Well, that's probably good enough for right now. And so hopefully you guys enjoyed this video. We're going to do another video because I see it's been 22 minutes now. And we'll explain the H-valve system, and we'll also explain the orifice tube system. So this is Professor Scott Norman, and if you're looking for more automotive educational videos, please subscribe to my Professor Pintane YouTube channel. Thank you very much. Have a good day.